So in the previous video, we saw that sometimes you will encounter text or words that are not part of your vocabulary. For example, this one that I showed now, um, we had a vocabulary that was coming from the verdict, and there was no word called hello in that vocabulary, and it was giving a key error. We're going to see that in code as well. But I want to, I just want to take this a step further, and then we can go into code. So this emphasizes a very very important point that your training data needs to be large and diverse enough so that when you build this vocabulary, it will include many different words and variations. So that is quite important. So in this video, we are not going to deal with large training data. We are going to put a stopgap measure for cases where where we encounter words we do not know, and we are going to add special tokens. Special tokens, because yes, sometimes you might encounter words you do not know, um, and there are some tokens that will help your model understand context better. So these are the special tokens that we are going to talk about. The two that we are going to include going to be markers for unknown words, and then a marker of document boundaries. Document boundaries. Those are the two special tokens we are going to discuss right now, or we are going to add. But we'll discuss other types. So for unknown words, we are going to create this token, which just means unknown. And then for document boundaries, we are going to create end of text token. End of text token. So what that then means is, I did say when we had that sample text, let me reduce the brush size again. We had a simple text. We had text like this. The brown dog, the brown dog playfully chased the stuff fox. That's the simple text that we had. I gave it as an example when we were introducing vocabulary. And I did say some people who are keen-eyed would have noticed something when we were tokenizing it into token IDs. What they would have noticed is when we break it down, it gives us the words correctly. Yes, brown. This is the tokenized, just the tokenized what? Brown dog as normal. And when we apply our vocabulary, so this is the vocabulary that we had. I'm not going to draw the squares anymore. So this is going to be brown. Brown was 0. Dog was 1, and fox was 2. But our vocabulary was composed of that the quick brown fox jumps over the lazy dog. That's what we had. It's going to fail this vocabulary mapping, just like we did with the hello. It's going to fail when it gets to the word playfully, chased, stuff. It's going to fail on those words because those words are not in our vocabulary that says the quick brown fox jumped over the lazy dog. They are not in there. So in order to avoid that failure, we can then introduce at the end of our vocabulary, we can extend our vocabulary by adding to these unique words their unique tokens. So here we add our unknown, and it will have the ID. Although our vocabulary here, I just said it was for those few words. Imagine our vocabulary is much bigger, so that this becomes maybe 783 ID, and then this end of text. End of text will be composed of, will be having another ID there. So what then ends up happening is when we have this vocabulary and after tokenizing, to get the token IDs, we do the lookup. We might now end up having token IDs that say 7 for there, and then 1 for brown, and then 0 for for um am I getting, no, 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 I actually wrote this correct, incorrect. Is 0 for 1 for brown, and then dog, we have a token of 1, token ID of 1. And then now when it gets to playfully, it will say I cannot find this word playfully in my lookup, so I'm going to use the unknown, and it's going to use the ID 783. So it will take the 783, going like that. Chased, it might, if it doesn't find chased, it will get 783 and all of that. That's all. Now these become our token IDs. The tokenizer encounters a word that is not in the vocabulary, so it will just replace it with that unknown. And what happens now when we are doing training of these big large language models? We know they use very large data sets, and if you recall from one of their papers, they were saying the data set that they use is composed of common crawl books and all of that, multiple books and all. So that is multiple different documents, multiple documents they use to train these large language models. So what we want to to insert a token before each new document or book. So what we can do is, let's say we have a book here, one book there, that is that is something like words like the underdog team finally clinched the championship. So it will then say whatever it's saying. It's a book that's talking about maybe a competition, and then it will say at the end, championship in a thrilling overtime victory. In a thrilling overtime victory. So this is one document. This is one document. That's that's a book, and then we're going to have another book, another document here, and that document could be talking. Elara and Finn um, lived with kindness and wisdom, enjoying, it's a fairy tale, enjoying their days happily ever after. That's the end of this fairy tale book. That's another document. Can I have another document? Can I have another document here? Another document could be talking about the Dow Jones finance. It's a newspaper article or whatever it is, coming from the Financial Times, and it will say the Dow Jones Industrial Average closed 250 points up, 250 points up today, marking the highest gain in 3 months. We've already read articles like this. That's what it ends like that. That's another document. And then the final one, another final document, could be talking about Emilia. Emilia smiled, knowing a journey, a journey had changed her heart forever. Had forever changed her heart, or whatever it's going to be. That's going to be another document. And as you saw from the previous videos, these guys when training these large language models, they were dealing, or they deal with billions and billions of words. So lots and lots of documents. So these are but with our 4 documents, we are now introducing what we termed here the document boundary. document boundary token. So let's see how that will happen. We are going to concatenate these texts into one text. And when we concatenate them, we are going to create something like this. Let me just cut off some of the words so I don't have to write all of them. So it will be saying in a thrilling overtime victory. And then we add the end of text token. We add this end of text token, and then we concatenate, we add the next document that says whatever it is, the whole book itself ending in happily ever after. Happily ever after. Full stop. Then we put the end of token again. End of token, this unique token. And we take the next, however many words are going to be in the next document, concatenate it there, and then we add that whatever it is in 3 months. That in 3 months, full stop. And we put that end of text again, end of text, and we add that one changed her heart, full stop. So this becomes our very long string with all our documents, all our documents. And what would then happen is we'll now modify our vocabulary, because we've seen this is how we are going to concatenate different texts and all of that. We've added special tokens. Let's go to our code and see that at work. So we're just going to go into Chrome, because it is useful for us to have these tokens. So we are going to, let me just jump into the codes to show you. For our hello, if we used our simple tokenizer, like I said, our simple tokenizer was going to fail, and we're going to run that. Sorry, we're going to run this. Our simple tokenizer was going to have this error because it didn't know in that vocabulary from that book, the verdict, it didn't know how to deal with hello. So it was going to give us our key error. That's when we decided to extend our unique tokens with the end of text and the unknown text, unknown unknown tokens, to create a new vocabulary that is now 1132. Remember, our original vocabulary was 1113. So now to print right at the end, we have younger, which is this ID, your, which is this ID, yourself, which is this ID, and then we have our two added tokens. So end of text is token 130, and our unknown is token ID 1131. So we now create a new simple tokenizer V2 that does pretty much what we're doing when encoding. But then if it says, if the item is not in our vocabulary, just put the unknown. Put the unknown. Replace that word like hello with an unknown. Because in our vocabulary, we know that we can look up the unknown. So the hello is going to be replaced by unknown token. That's pretty much what it's doing here. That's it. So we updated our encoder and just put our simple tokenizer v2. Now, when we apply the simple tokenizer v2 to hello, do you like tea? Or in the sunlit terraces of the of the palace, we now have our two two texts, text one and text two, and we are going to concatenate them with an end of text. So, hello, do you like tea? End of text. In the sunlit terraces of the palace. That's it. Now, when we encode the text, the hello is going to be encoded by the token ID of unknown, and then all the other ones that we know. And then the end of text itself, this token end of text, is going to be encoded with the token ID 1130, because that's what we added to the vocabulary to do the lookup. And that's it. So now this is the new tokenized text. And we can now encode that, and we can encode these IDs. We can encode those IDs, or and then decode them. So here we're encoding them into IDs, create the IDs, and then we're decoding them. So these IDs are now just being decoded. Now you see it returns unknown instead of hello. Do you like tea? And then it returns end of text, and then returns the other returns the other words. But then for Palace, Palace was not there in our vocabulary, so it returns again unknown. So for that part now, depending on what large language model you are going to be using, some large language models they use different special tokens. Other large language models, I'm just switching to this one here, to the whiteboard. Other large language models and researchers, they use special tokens like beginning of sequence. So this just points to where the sequence is beginning, end of sequence. You might have seen these. I think Llama, if I'm remembering well, the first Llama, I think they were using end of sequence. You actually see these EOS, end of sequence. It just highlights where the sequence is ending. It works sort of similar to end of text. And some of them, they use pad, which just means padding. So padding works when sometimes when you're training these large language models, most of the time, when you have a batch size, you because you have these many documents or many words, you might batch them for you to train better. If you've trained neural networks before, you probably understand what batching means. You just batch them. You say, okay, let's just say, as an example, I have 10,000 texts, but I do not want to process these 10,000 texts because it's going to be memory intensive and all of it's going to take time for you to process these 10,000 texts at once. I'm going to batch them into 1,000 texts each, 1,000 into groups of 1,000, which means now you have 10 batches. But inside each batch, because the texts could have different lengths, imagine there are tweets. There are tweets. You have 1,000 tweets. Some tweets are going to be 50 characters long, some tweets are going to be 100 characters, some 160, and all of that. The use for padding is to say, okay, for me to really deal properly with these texts, I need them to be rectangular. So I'm going to take the longest tweet, which is 160. That is the length. For the ones that are less than 160, I'm going to add padding. And then you just add these tokens, pad. For this one, you add 60 pads. And for this one, yeah, you add 110 pads. So it'll be pad, just to make sure that they have the same length. So that's what some researchers do. They add the padding token. But for GPT tokenizer, for GPT tokenizers, the tokenizer for GPT models, they do not use these special tokens. It only uses this end of text token. Um, End of text. And this was done for it to be simple, and also uses this end of text to act as a pattern. So here it will be end of text, end of text, end of text 100, 100, 110, 110 times. Um, it also doesn't use the unknown, this unknown token. The reason for that is they use something called um, byte byte pair encoding, and that is what we are going to explain in the next video. So stay tuned for that video.